Hello and welcome to another edition of Book Review here at CCXP Exam Simulator. This is Michael Bartlett, and today I'm going to be reviewing a book called Applied Artificial Intelligence, a Handbook for Business Leaders. I got this book off Kindle a few days ago. It was a pretty quick read, and the reason I was interested in looking at it is I was looking for a text that would be suitable for executives or people at the C-level, and I think the book actually accomplished that, so I'm going to go ahead and give you my top notes from the book. So the first thing I want to do is, and I've not done this before, but I want to stress that this book review is being done in 2019. AI is a technology that is evolving so rapidly that this book and this review are probably going to be out of date in a few years. So if you're watching this in 2022 onwards, you may want to look somewhere else, because I'm sure that this is completely out of date by then. But for the here and now, I think that everything that's contained in this book is pretty relevant. So here are the notes. So to start off with, they talk about machine learning as a service. You've probably all heard of software as a service. So basically what they're talking about is you could either go out and build your own technology, or you can leverage one of the big players, Microsoft, Amazon, and so forth, who have complete end-to-end solutions that they call machine learning as a service. So the other day I was looking at Microsoft's, which is called ML.net, which stands for machine learning.net. I watched some of the demos that they did, incredibly powerful. Obviously you can move some of that computing into the cloud, or you can do it locally, but it just makes, like if you want to run sentiment analysis or anything like that, you don't need to code all of that from scratch. This stuff's already there, it's built for you, and you can integrate it into your code. So that's a new concept, machine learning as a service, but something that we're going to see more and more of in the future, and something that if you're an executive should be in consideration along with building your own bespoke solutions. It's important to note that sometimes simpler AI approaches can result in faster and more accurate results than fancy neural nets. Deep learning algorithms need to see thousands of examples to achieve reasonable accuracy, and even then they are still prone to error. So this is really just a cautionary point. Anyone who works with neural networks quite a lot will know that there's different challenges that can be associated with them. A lot of the stuff comes down to the data as well. Obviously you can achieve phenomenal results if you've got really good data, you've got a really good approach in terms of your training and your test data sets, and you've got enough information. But all of that is considerations that have to be thought about when you're looking at an AI implementation. And you know what? Sometimes just a really simple solution can work. I was looking at key driver analysis recently, and there was a video I watched where someone was talking about using random forest regression, and it was looked very complex to get the thing up and running from scratch. Or you could just literally go into Microsoft Excel and run a regression analysis. So there's simple approaches out there that may give you enough. I mean, in this is a quote from their book, and they're saying sometimes the simple solutions can be more powerful, even if they're not. Even if they get you 85 to 90% of the job done, if that's good enough, you have to decide what's good enough in your organization. That may be a good trade-off in terms of all the months of development you may have to take on to build a big deep learning solution. Which, of course, I wouldn't recommend. I'd recommend using something that's already in existence, like TensorFlow, or something that's produced by one of the big players. This book gives a nice high-level overview of all modern AI techniques. So the big two areas are kind of supervised learning and unsupervised learning. They talk about semi-supervised learning as well. A good example of that would be if you've ever used Watson on a chatbot. I used it when I was signed up for Geico Insurance, and after every time that the AI gave me an answer, there was a little, was this useful, thumbs up or thumbs down. So, there was no human sort of, analyzing and curating all the stuff in advance. It was attempting to learn on its own from that feedback. So it was kind of semi-supervised. So I thought that was a nice breakdown of those high-level three. Then it goes on to talk about some individual techniques like clustering. I was very impressed to see that genetic algorithms were there. Right now, Uber is doing work here in 2019 with evolutionary algorithms that are outperforming deep learning. So, and I mean, genetic algorithms have been around for years. They were created by John Henry Holland. I can't remember what decade it was, but it was a long time ago. I learned about it in the 90s in one of my college classes on AI, and unfortunately the processing power just wasn't there back then to allow them to do what they can do now. But yeah, genetic algorithms, mutation, all that kind of stuff is very, very interesting. Novelty search is a new one that they're doing now, and it's just a very exciting field. So good to see that got a mention. They say the most successful applications of machine learning to solve enterprise problems use something called ensemble methods. So I'm going to read you a quick excerpt here. So there are 4 broad categories of ensembling. They're known as bagging, boosting, stacking, and bucketing. This is all quoted verbatim from the book. Bagging entails training the same algorithm on different subsets of the data and includes popular algorithms like random forest. Boosting involves training a sequence of models where each model prioritizes learning from the examples that the previous model failed on. In stacking, you pull the output of many models. And in bucketing, you train multiple models for a given problem and dynamically choose the best one of each specific input. Bucketing, I've seen in the ML.NET videos. They try a whole bunch of different algorithms and pick the best one. One of the other techniques mentioned earlier on was also used actually when I was doing my master's degree in artificial intelligence back in 1999. It was a natural language processing project. And the guy didn't do anything new. He just aggregated existing agents that had already been built to classify, whether it was a noun or a verb or whatever it was in the lexicon, and was able to achieve a much more accurate final score by using all of them. They talk about something called the machine intelligence continuum. So they break it down into different layers. So there's systems that act. So you can think of those as expert systems, any system that follows if-then rules. Systems that predict. So they gave a really good example in the book about how Target now has enough intelligence on people that if you buy one or more of a particular group of products in a certain time range, they can actually accurately predict if a person's pregnant and how far along they are. And then there's systems that learn, so obviously things that self-adapt, self-learn, and then create. So systems like there's one example they gave in the book of a Beatles song that was generated by a system that kind of learned and got a feel for what the Beatles music was, and it can produce new hits. They did talk about 2 other ones, but I didn't think they were very relevant, to be perfectly honest. So I'm not going to go into them in this review. I think those 4 are enough for now. When you go further than that, then you start talking about things like artificial general intelligence, which is trying to make an AI that's almost like a human that can learn anything that's completely brand new to it. And where we are right now, we don't even need to be thinking about that kind of thing, because AI really right now is more of a tool. I saw a very interesting documentary recently that basically said the Industrial Revolution allowed us to go beyond our physical limitations, and what AI is going to do is it's a tool as well that will allow us to go beyond our cognitive limitations. They said you can use these ideas when you're evaluating vendors, because everybody's trying to hype up the latest AI now. Everyone's trying to say they've got some hot AI solution, and they said most vendors actually have systems that either just act or predict. They haven't gone any further than that. They spoke wonderfully about data. I heard a really wonderful quote recently. Data is the new oil. And I thought that was a fantastic and very profound quote as well. They say data is not ground truth. Ground truth is something that is universally accepted as being unambiguous and the truth, the de facto truth. Data is a human construct, as are the tools that we use to gather it. So you should know the reason for collecting data. If you don't even know the reason you're collecting data, then why are you even looking at it? So they had a really good chapter that went really in depth into data, some of the problems that can come from data collection if your methods aren't sound, some of the biases, that kind of thing. So that was very useful. They say having and using a fantastic machine learning algorithm is less important than deploying a well-designed user experience. I totally agree with this. At the end of the day, it doesn't matter how savvy the algorithm is. If it doesn't translate into a good user experience, then what's the point? In fact, sometimes it might even end up with a bad user experience. They say you need to tackle technical sprawl and nurture a culture of data-driven decision-making before looking at AI. So let me read a little passage here about technical sprawl. So I'm quoting from the book here. Technical sprawl can be defined when different business units implement their own initiatives without consulting each other, build conflicting or incompatible solutions, compromise security due to inconsistent standards and access, and overload IT departments that struggle to monitor and manage everything. They said here, if unaddressed, technical sprawl will lead to your company investing in fits and starts and buying third-party AI products for narrow purposes, which will only exacerbate your existing problem. And then moving on, they talk about organizations have 5 levels of analytical sophistication. This comes from someone who works for LinkedIn. So basically, are you looking at what happened, which would be your data? Are you then looking at why did it happen? So getting information about that. Then saying what will happen. So being able to have intelligence. What's the best thing that could happen? So now we're getting into the insights. And finally, how can we automate continuous transformation, which is where you elevate to the levels of making change and impact. So I thought that was an interesting model, something to think about when you evaluate your own organization for AI readiness. They talk about picking a true north metric for each major project to know if your AI strategy is creating a long-term and sustainable value. Let me read you a little quote here about their north metric. So I quote from the book. Even after you've ascertained that an AI initiative is likely to positively impact the bottom line of your business, you need to define a more specific true north metric for each major project in order to keep your machine learning projects on the right trajectory. Goals like increase revenue by X dollars or cut costs by Y% are almost always too high level to be useful, since a confluence of intermediate factors drive your end result. Choosing a more specific metric helps you to qualify your AI strategy and also check that your decisions align and advance your business and technology in the right direction. Facebook's true north metric for platform growth is the number of members who connect with 10 friends in 7 days. Just having a user sign up for an account is insufficient to inspire the engagement rates that Facebook needs to later monetize that user through advertising. And finally, use machine learning as a safe way to refer to artificial intelligence without all of the weight of expectation. Even people that are very well versed in artificial intelligence will disagree with one another on what the actual definition means. And playing the definition game sometimes is a bad idea because people are just going to go around in circles. Certainly when I first heard the term machine learning, I was quite confused. And I'm like, so how is this different from AI exactly? And so what they basically did in the book is they said, for the purpose of simplicity, we're just going to refer to them as the same thing. But what their recommendation was is if you're trying to get buy-in within the organization to do some kind of an AI project, it's probably a good idea to use the phrase machine learning rather than artificial intelligence, because when people think of artificial intelligence, it comes with a whole bunch of other stuff associated with it, like I mentioned earlier, artificial general intelligence. So at least that way they can understand that it's going to be more basic and more around solving problems for the staff members in the company, and they're not going to expect something all-encompassing, all-incredible AI that I think sometimes people might do when they hear that phrase. It's just been so hyped up lately, unfortunately, which happens every time we get one of these little AI bubbles. This isn't the first one, and it may not be the last one. So anyway, I hope that review was useful. I definitely think that this is a great book to get if you're somebody who's in an influence position and you want to try and get leverage within your organization to persuade the CEO or someone in the C-suite to get on board with an AI project. If you're obviously in one of those roles, I think this would be useful as well. Although you're probably better off just trying to get a 1 or 2 page summary, because it is a book that's over 200 pages. So I hope you found that useful. If you guys want to see any more book reviews, just drop me a line on the email address shown on the screen, and I will be back with another one again soon. Thank you.